Hello, ladies and gentlemen. We are going to do section 4.5 today, solving our quadrilaterals by taking roots. We have a few objectives today, so we actually have a little bit more information to cover today. So our objectives are going to be review properties of radicals, then we're going to do some math on radicals, and then we're going to solve our quadratics. So those are our three tasks today. I will show you kind of a new way to reduce a radical, but let's get started with some definitions. So if I have a square root, we talked about this the other day in class just a little bit, but if I have r times r, that gives me r squared. And if I take the square root of r squared, it gives me r. So a square root is 2 of the same number multiplied together. So your job when you have to simplify a radical is to find what numbers reduce and come outside of the radical, because the square root of two numbers is an individual number. Okay, so let's talk about just some definitions. Let's say I have the square root of x. The symbol itself is called the radical sign. The thing underneath the radical is called the radicand, kind of a weird word. And then both of those things together make what we call a radical. Okay? Now let's talk about some properties of our radicals. We're not going to talk about all of the properties right now, but just a couple. The first one that we want to talk about is the product property. So if I have the square root of a times b, I can get the same thing by doing the square root of a times the square root of b. So the product property says that I can split up a multiplication problem into two separate radicals. Okay? So for example, if I have the square root of 18, I could write that as the square root of 2 times the square root of 9. And we know that the square root of 9 is a perfect square, so this is going to be 3 radical 2. So the square root of 9 is 3, and then there's my radical 2. The next property that we want to talk about is the quotient property. And that says if I have the square root of a fraction, I can split that up into two separate pieces as the square root of a over the square root of b. Okay? And we'll talk about what happens in a little bit if I have a radical left in the denominator. So if I have the square root of 2 over 25, I could rewrite that as the square root of 2 over the square root of 25. The square root of 2 doesn't simplify, but the square root of 25 is 5. Alright, so a rule that you want to remember is no radicals in the denominator. And in just a bit we'll talk about how to undo a radical that's in the denominator. But for right now I want to take a little trip And if I have a radical that needs to be reduced, I'm going to show you a new method. Okay? And I actually am not picky about how you reduce your radicals, but I'm going to show you the method that I've learned, and it's called a factor T. Alright, so let's say I have a square root of 98, and I need to reduce that radical. So I would write 98 at the top of the T. The numbers on the left-hand side are going to be prime numbers. And remember, the definition of a prime number is any number whose factors are 1 and itself. And then the numbers on this side are going to be the quotients. And that is the answer when I do division. So the first number that I'm going to divide into 98 is 2. And 2 is prime. So 2 goes into 98 49 times. Then 7 goes into 49 7 times, and 7 goes into 7 1 time. So you're done with this method when you have a 1 in the bottom right hand corner. The square root of 2 7s means that 1 7 can go outside. So we're going to call those guys buddies. If you have a buddy, you can go outside. If you do not have a buddy, you have to stay under the house. And we're only looking at the numbers on the left-hand side of the T. So the radical 98 reduces to be 7 radical 2. Okay? I could also have done this by doing the square root of 98 is equal to 49 times 2, and that's 7 radical 2. The problem is sometimes I don't know what the factors are that give me the perfect squares. This is a very quick and efficient method, and that's how I reduce my radicals. So just to review this one, your prime numbers go on the left, and then your quotients go on the right. Okay, and then you get to stop when you have a 1 on the bottom right. The other thing that's key is you can leave the house when you have a buddy. Kind of a funny method, but it always works. Alright, so let's do a couple of examples using our method of reducing radicals. Alright, so let's say I want to reduce radical 42. Again, I'm going to use my factor T. So I'm going to write a 42 at the top of a T. I'm going to divide 2 into 42, and I'm going to get 21. Then I'm going to divide 3 into 21 and get 7. And then 7 goes into 7 one time, and I have a 1 on the bottom right, so I can stop. Notice there are no pairs of like numbers, so radical 42 is already reduced. It can't reduce any further. Alright, so let's do another one. Let's do the square root of 80. So if I write 80 at the top of my factor T, and I'm going to start dividing by prime numbers. I'm going to start with a 2, and I get 40, and I'm going to divide by 2, and then I get 20, and I'm going to divide by 2 and get 10. 2 into 10 gives me 5. 5 goes into 5 one time. So now I can stop. I have 1, 2 sets of 2's. He has no buddies, so he has to stay in the house. So this is 2 times 2 radical 5, which is 4 radical 5. So that's kind of a fun way to reduce a radical. When the numbers are bigger, it's a pretty quick and efficient way to reduce the radical. All right, the next thing that we're going to talk about with our radicals is what's called rationalize the denominator. I mentioned earlier that there are no radicals in the denominator. If there are, then we have to manage them. The way that I manage a radical in the denominator is through multiplication. So let's say I have 5 over radical 2. The way that I rationalize the denominator is multiplying by radical 2 over radical 2. And notice that this reduces to 1. So I haven't changed the value of what I'm doing, but I've simplified it. So on the top, in fractions, the numerator multiplies together and the denominator multiplies together. So I'm going to get 5 radical 2 on the top, and then radical 2 times radical 2 is radical 4, and then that simplifies to be 5 radical 2 over 2. I can have a radical in the numerator, but I can never leave one in the denominator until later in the year. But for right now, we always want to get rid of the radical in the denominator. All right, so let's do another example of these. I'm going to do 7 divided by 4 radical 3. Now the 4 is fine, but the radical 3 is not. So I'm going to multiply by radical 3 over radical 3. So on the top, I'm going to get 7 radical 3, and in the denominator, I'm going to get 4 radical 9. So this is 7 radical 3 divided by 4 times 3. So this is 7 radical 3 over 12. Okay? Anytime you have a radical and multiplied by the same radical, it always gives you what's underneath. But if you need to, you can write down that step so that you can see what happened. All right, now let's do an example with the problem written in a slightly different way. Let's say I have the radical 5 over 2. I can simplify that by our properties to be radical 5 over radical 2. Now the radical 2 is a problem, so I'm going to multiply by radical 2 over radical 2. So I'm going to get radical 10 over 2. Okay? This 2 cannot reduce with the 10 because this 2 is outside of a radical. So things that are outside stay outside. Things that are on the inside stay inside. All right, so now let's do another type of problem with radicals. So let's simplify. What if I had radical 10 times radical 15? I could do this as 2 times 5 and then times 3 times 5, because this is the 10 and this is the 15. Now the two 5s can come out, and so I'm going to get 5 radical 6, and then that one would be reduced. Things can only go outside from the radical as long as they come outside in pairs. So if I did another one like this, and I did radical 8 times radical 28, I'm going to write 8 down, and I know that this is 7 times 4 and this is 4 times 2, so I'm going to write it down as 2 times 4 and then 4 times 7. If I have a pair, I can go outside, so it's going to be 4 radical 14. And then that one is done. Alright, so now we've done some radical work. Now let's actually solve a quadratic. So if I get ready to solve my quadratic, and we've actually been solving quadratics in lots of different ways, but let's do an example. and I'm given 3x squared plus 5 is equal to 41. Notice that there's not any other x terms, so I'm actually going to take the 5 to the right, and I'm going to get 3x squared is equal to 41 minus 5, which is going to be 36. Then I'm going to divide both sides of the equation by 3, and I'm going to get x squared is equal to 12. Now I can take the square root of both sides, and I'm going to get x is equal to plus or minus the square root of 12. Remember, every even root has two solutions, and we talked about that a couple of days ago, but every even root has two solutions. Now I just need to simplify my radical, and so x is going to be equal to plus or minus, this is, sorry, I'll go back a step, this is 4 times 3, so this is going to be 2 radical 3, and there's my answer from our first example. Okay. Now let's do one that's a little bit different. We haven't seen many that have actually shown up like this, so again I'm going to solve, and this time my equation is written like this: 1/5 x plus 3 quantity squared is equal to 7. So now what I'm going to do is manage the 5 first. So I'm going to multiply both sides of the equation by 5. So I'm going to multiply this side by 5, and I'm going to multiply this side by 5. These two 5's cancel, and so I'm going to get x plus 3 quantity squared is equal to 35. Now I'm going to take the square root of both sides because the opposite of a power is the root. So I'm going to take the square root, and I'm going to take the square root, and I'm going to get x plus 3 is equal to plus or minus the square root of 35. Now I'm going to subtract 3 from both sides, and so I'm going to get plus or minus radical 35 minus 3. And then I'm going to rewrite it because usually we write the normal numbers first and then our slightly abnormal numbers second. And that would be my solution. And that would be my two solutions because it's a second degree polynomial. I still have two. I have technically a negative 3 plus radical 35, and I have a negative 3 minus radical 35. You do not need to get a decimal equivalent. This is fine. This is actually the best kind of answer you can have. All right, so now one more topic, and I want to talk about a conjugate. So when I have a radical in the denominator, as long as there's one radical in the denominator, then I can just multiply by the radical like we've done in our previous problems. But now what happens is if I have a fraction, I need to manage it a little bit differently. So let's say I'm given 1 plus radical 2. The conjugate of that expression is going to be 1 minus radical 2. And let me show you what happens why we have a conjugate. So it's always going to be the opposite sign to get the conjugate. When I multiply these two things together, the radical disappears, and that's the purpose of a conjugate. The conjugate makes the radical disappear. So let me do a box to show you. So if I had 1 radical 2 and 1 minus radical 2, I would get 1, and then here's the radical 2, a positive radical 2, and a negative 2, because a radical 2 and a radical 2 is going to give me a 2, and I keep the negative. This term and this term cancel, so I get 1 minus 2, or a negative 1. So the whole purpose of a conjugate is to make the radical disappear. Okay? So let's do another couple of examples, and I'll show you what happens with the radical. Alright, so for our next example, I'm going to be given 6 plus radical 5, the conjugate of that is going to be 6 minus radical 5. And let me just show you what happens when I multiply those two together. So if I do 6 plus radical 5, and I multiply by 6 minus radical 5, and I'll do the box to make sure that we don't lose any terms. So I have 6 radical 5, 6 minus radical 5. I get 36 minus 6 radical 5 plus 6 radical 5, and then minus the square root, of 25, which is a minus 5. This term and this term cancel, and so I end up with 36 minus 5, which is going to give me 31. So the purpose of a conjugate is to get rid of the radicals, okay? Sometimes I say get rid of the problem child, and the radical is the problem child. So what if I had 3 minus 4, radical 4, and I can't spell, try that again, U-G-A-T-E, the conjugate would be 3 plus radical 4. So notice that the two signs are always the exact opposite. Alright, our last example is going to be managing a fraction with conjugates. So I'm going to give you, and I'll do one of these, and then you can start your problems. Alright, so there's the fraction that I'm given. I can't just multiply by radical 3 over radical 3 because I have a 1 minus. So now what I have to do is multiply by the conjugate of the denominator. So in this type of situation, you solve by multiply by the conjugate of the denominator. And you multiply it by the top and the bottom. So if I have my given fraction, I'm going to multiply by 1 plus radical 3 over 1 plus radical 3. And notice that's just the conjugate of the denominator. Okay? If I distribute across the top, I'm going to get 2 plus 2 radical 3. And then I'll do my other math over here on the side, and then I'll tell you the shortcut, 1, and then there's my radical 3. Here's 1, radical 3, negative radical 3, negative 3. These two disappear, and if you'll notice, the middle term has gone away every single time. It actually always goes away. So I'm left with 1 minus 3, which is a negative 2. So that's going to be my denominator. Now I have to finish this fraction, so I'm going to divide 2 by the negative 2, and then 2 over radical 3 by the negative 2, and then I'm going to get a negative 1 minus 1 radical 3, and that is my answer. So if you remember that the middle terms cancel when you multiply by a conjugate, you can go straight from this step almost to here. I would at least go from the 1 and the negative 3 because the middle terms always cancel out when you multiply by a conjugate. Alright, so this is near the end of your video. So now here are your problems. Okay, so you have 4 today. There are 4. Number 1 says to simplify the radical, and you're going to have the square root of 150. That's your first problem. The second says simplify, and you're going to have 7 over radical 12. Number 3 also says to simplify, and it's going to be 1 over 5 plus radical 6. This one is a little bit more challenging, but you can do it. And then your last problem says to solve, and it is 7x squared minus 10 is equal to 25. All right, so there are your 4 problems. Good luck.